So in this series of videos, we're going to learn some more shortcuts of taking derivatives with new types of functions. So the first one we're going to look at is the product rule. All right, so far, we've learned how to use the power rule, so we can take the derivative of this to get 4x cubed. We learned how to do some trig functions, so the sine is cosine, and some exponentials, so e to the x is e to the x. So we've learned those already. We could also add and subtract these, so if we had x to the fourth plus sine of x, we could take the derivative of that as well. But what happens if we start multiplying functions together? If we want to take the derivative of y equals sine of x. The most common mistake students are going to make in general once we start doing these types of derivatives is saying that the derivative would be, well, the derivative of x is 1, derivative of sine is cosine. I say kind of just take the derivatives of the two parts, but it's going to turn out this is not the correct answer. So we have to do this entire other thing when we have to do the derivative of two functions being multiplied together. And this is x times sine of x. So we have to do this thing called the product rule. All right, here's the product rule. All right, so again, product just means things are being multiplied. So we have these two functions. F is being multiplied by g. All right, in our last example, f would be x, g would be sine. All right, and then the formula for this, when we take the derivative of this, all right, the way I like to think of it is you keep one function the same. So I keep f of x the exact same, and then I take the derivative of the other function. So we have this little prime here. All right, that represents we're taking the derivative of g. So we keep f the same, and we multiply that by the derivative of this. And I made a mistake here. This should be a plus sign. Oops. Plus sign. And then we do the exact opposite. Now we're going to keep g the same. That's our original g function. And now we take the derivative of f. All right, so this is the product rule. Whenever you see multiplication and you're taking a derivative, you have to do this product rule of getting these four different terms, the original function f, and the derivative of g, and then you switch them, the original g and the derivative of f. All right, so let's see what it's going to look like when we do an example. All right, so we're going to take the derivative of this. There's kind of two different ways you could do this derivative. The first thing is you could FOIL it and then use the power rule. All right, so that's the way we kind of would have had to do this problem before, but now we can also do this derivative using the product rule. All right, so this is our function, its derivative. All right, what we're going to do, let's call this one the red one, this one the blue one. All right, so the first thing I'm going to do is I'm going to keep the red one exactly the same. I'm just going to type or write down exactly what the red part is. And I multiply that by the derivative of the blue part. The derivative of the blue part, using the power rule, is 10x plus 6. And then I add, all right, there's a typo in the last slide, all right, but I add, now I do the opposite. Now I'm going to keep the original blue function, and then multiply that by the derivative of the red function, which is going to be 3x squared. And you could simplify this and everything, but this is the basic idea of, all right, our red function, keep it, take the derivative, blue function, take the derivative, and keep it. Oops, I drew it into the wrong spot. There. All right, but so you're always taking the derivative of one and keeping the other one. All right, so here's the kind of motivating example we had. All right, x sine of x. We know the answer is not going to be cosine. All right, when we take the derivative of this, yeah, let's call this red and this blue. All right, our derivative. All right, keep x, multiply that by the derivative of sine, which is cosine, plus keep sine, multiply that by the derivative of x, which is just 1. All right, so we don't even have to really write that last piece. So x cosine x plus sine is going to be a derivative of x sine of x. Again, just going through, making sure you identify what the two parts of your problem are, and then just doing the correct pattern. All right, here's one. All right, you can pause the video, try it on your own first. All right, do the product rule, and then come back and see if you get the same thing that I do. All right, so what I'm going to do, again, I like to kind of identify the two functions I'm working with. So that's my red one. This is my blue one, my f prime of x. And it doesn't really matter because there's a plus sign in the middle which one you keep first and which one you don't keep first. All right, let's keep the red one first. All right, so keep that the same. Then we multiply that by the derivative of the blue function. Derivative of e to the x is e to the x. And we add, and now we keep the e to the x function and multiply that by the derivative of the red function. We get that final answer. All right, a lot of times when you see this answer on like a multiple choice question or something for an AP question, what they'll do is they'll take these e to the x's and factor them out. Right, so a lot of times you'll see it like this: e to the x times x to the fourth minus 5x cubed plus 4x cubed minus 15x squared. And you could even combine those like terms in the middle. All right, so you'll see this as the way that it's written for the final answer on AP multiple choice questions a lot, because this e to the x ends up popping up in both of these pieces. All right, but for right now, the product rule, all right, as long as you can get to here, you're doing it right, and then we'll kind of, as we work through practice problems, work on simplifying and things like that. All right, so this is the product rule. Just know whenever you see multiplication between two different pieces and you're going to do a derivative, you have to do this product rule.